So the name of the chapter means like if a current flows in a wire, then it will produce a magnetic field. That's why the word electromagnetism is brought here. Terrestrial magnetism is different, electromagnetism is different. Terrestrial magnetism is where the magnetite or magnine, what you can call Fe2O3, it will produce the magnetic field due to the different composition of the material. Like that will have a type of material like a dia, para, ferro. We're not talking about the magnetism here, classical magnetism. We are talking about the application. Means a current carrying wire will also be like a magnet, and we are going to study the applications of that one. That's why the name of chapter is called as the electromagnetism. So for this, I'll begin with a chapter, the topic, the Biot-Savart law. Then I'll enter into this is there for next week, but I think we need some information of this because as we discussed, numericals now all are related, linked with Biot-Savart law. So it's like a how Coulomb's law, no? This is also like a fundamental law where it will tell us the magnetic field due to any current element. Current element. So what is the symbol for this? This will be I into dl bar. Dl is what? Small element and I. This will become current. It's similar to like a point charge. In electrostatics, what we had a elemental charge we call point charge. No? Similarly, an elemental current carrying structure is called as a current element. So what is the meaning of that? Suppose if there's a wire is there, this will carry a current of say like a 2 ampere. I'll take a small element. Let me pick up a small element. The length of this dl. The current is having some specific direction. The length of this say like a 0.1 centimeter. So what is the current element now? I into dl. And the direction of current element is given by the direction of current. dl is small elemental length. Here for to make you understand, I made dl 0.1. It can be even micrometer, nanometer. dl I'm writing that one. So why we are bringing it? So what is a current carrying wire? Shall I assume that it is made up of such current elements? So how to express a current carrying wire? I just assume that the wire is made up of such current elements. The wire is made up of such current elements here. Now first what the Biot-Savart law, it will tell us the field due to this particular current element. Then once we know that, like as we in electrostatics, if you know field due to point charge, definitely you can find out field due to any other charged object, like any other charge object. Similarly here, if you know the field due to current element, you can find out magnetic field due to any other current carrying element. So let me assume there's a wire. It's a wire. So I'll assume a small here a current element. So what is the direction of the current? The current is flowing in this direction. Then what is the field strength at a distance r? So at point P, so what is the magnetic field strength? So let this be the theta. Theta I'll measure from current element to the position vector. This R bar you can put it. So this is the current element, dl. So what is the magnetic field strength at point P? So that is the law what it says, dB bar is equal to mu naught I dl bar cross r cap by 4 pi r square. If I further expand this, so this will be only in the magnitude, I dl bar cross r bar. So what is the direction of ideal bar here? Here it will be like this, ideal bar. R cap, R cap will be, it's a unit vector directly along the position vector. So therefore they should be equal to ideal sine theta 4 pi r square. The expression for the magnetic field due to current element, not due to wire it is. This is a wire. There's a wire. What is a wire? Some iron, any metal, any conductor. Through it, what happen? A current I is flowing. Then I'll assume a small element. Then magnetic field that due to small element here, it will be. So what about the direction? You can take right hand screw rule. Curl fingers from current element towards point P. The thumb will at point P. The thumb will be into the plane. This one, or you can go for right hand thumb rule. So what is the right hand? So what the right hand thumb rule it says? Curl fingers like a curl fingers this one or put thumb in the direction of current element. Means just hold like this. Now what is this blue color line? It's a current carrying wire. It's a current carrying the wire itself. So I'm going to hold it in my hand, that one. Then I'll put the thumb in the direction of the current. Then whatever the magnetic field are given by the fingers. So how the lines of force will be? The lines of force due to this current varying wire are given by the fingers. Thumb should be pointed in the direction of current. The fingers will give the direction of B bar surrounding the wire. So this is a wire. Okay, look at this. This is about now thumb in the direction of this one. So the current here will be. So what the fingers will indicate the direction of current here. So if I show that in the, so if you look at the this one, so this will be the direction of current inside. This will be the current I flowing. So concentric circles is what? This will be concentric circles. The direction of current is given by these arrows here. What is this cross? That is a current I. There is a current carrying wire. What is that into mark? The current flowing in the direction. It's a plane diagram. You may get many situations like that. If a current I is flowing through a wire, I'll magnify a little bit. Here, let me show. Okay, find this one. So there's a wire, current carrying wire. Current is flowing into the plane, along the wire, that one into the plane. So how the lines of force will be like this. So if you draw a tangent, here, the tangent drawn on the lines of force will give the direction of B bar. If the current is flowing out of the plane, we show circle dot like this. This will be. Then the lines of force will be okay. Draw a tangent. So no, the lines of force, how it will be? It will be in this direction. So if you draw a tangent at any point on the lines of force, So you are going to get the direction of B bar. So what are that blue color circles with red color arrow? They are the lines of force. Lines of force. And what is this? This is a long wire. It's a long wire. Like that, open the lines of force till infinity. We have to keep on increase the radius. This will be so definitely. So just take the pen or pencil what you have. So assume that direction is flowing in one direction. Hold that pen or pencil. Then put thumb in the direction of one assumed direction. The fingers what happen, you are going to wrap around the pen or pencil. No? So the direction of the fingers what happen will give the direction of lines of force. And if you draw a tangent to the lines of force, you'll get the B bar. So look at the magnetic field. It will be. So definitely what happened here, what is the Biot law? Only due to current element. Due to long wire, we don't know. Are you getting all of you? Due to long wire, we don't know. Only due to the current element is what the Biot law is telling that one. So what is this D bar? Due to current element. The field only due to current element is what this particular Biot law is giving. It just obeys the, like similar to Coulomb's law, no, fundamental law, how the magnetic field proportional to obeys inverse square law, and it is defined only for current element. No, roughly can we say what is the direction of B bar here? Will be into the plane. Shall I put like this? Cross mark. No, it's not a wire. The direction of B bar. Nearby magnetic field. If I draw like this, what does it mean? The B bar is into the plane. What about here? How the field here will be out of the plane? Don't get confused again this with a wire. Okay, wire I'll show by green color. Huh? Okay, clear this one. So the direction of B bar will be in this way, that one. So whenever plane diagram comes, okay, take help of the right hand thumb rule. When it's a 3D diagram comes, take help of this vector concept or cross product. Fine, all of us. What is theta? Theta is the angle between current element and the r cap or the position vector. So we'll define that also. Theta is angle between current element and position vector. Okay, let's go for some application. There's some standard structures. We'll try to find out what is the magnetic field.